Hey y'all, welcome back. Today we are going to continue our unit on previewing what you're going to see next year in geometry. And so far we've looked at a couple different skills, including how to simplify and combine square roots. And then last time we looked at how to deal with line segments. And we focused on the segment addition postulate. Today we are going to start looking at what are known as angles, and we'll go through a lot of vocabulary that you need to know. This is going to be a two-parter here because there is a lot of vocabulary with regards to angles. So we'll focus on some of it today, and then we'll go over the rest of what we need to know next time. And these are the last two lessons for this last unit, and they will give you a good idea of what to expect in the early stages of your course next year in geometry. So let's jump into, define what an angle is and give some examples and go through a lot of vocabulary that you'll need to know. An angle is just a set of points consisting of two different rays with the same endpoint, and we call that endpoint a vertex. There's a couple of diagrams down here of angles, and you've probably seen these in middle school before. Generally speaking, the way you sketch them out is you just draw two rays. You have one coming out like over here and then another one, and the key is that they have the same endpoint. I'll draw these arrows up front, but just to kind of simplify, I might leave them off, but usually you're going to see that there's arrows going in both directions. These are supposed to be rays. And if you are unaware, a ray is simply a line that only goes in one direction. So it's like a line that has a stopping point. Now we do have a point here where the two rays start. This little endpoint right here is the endpoint they share. That is called the vertex. So this little point right here is what I mean by the vertex, and I'll use that word pretty frequently. So here's the vertex, it's right here. So this is what an angle basically looks like. Now what you're measuring when you're measuring an angle is it's a little bit different. You might be used to measuring things like distance or weight or volume and things like that. Well, an angle is a completely different kind of measurement, and instead of measuring, say, a distance from point A to point B, what you're measuring is an amount of rotation from one ray to another. So imagine I have this horizontal ray down here, and I turn it kind of like the hand of a clock. But I would go counterclockwise in this direction rather than clockwise. But let's say I rotated it and ended up where this secondary ray was. Well, that amount of rotation, as shown by this little symbol right here, this little curve, is indicating the angle. And the more rotation you have, the larger the angle, the larger the measure of the angle is. So, for instance, if it's completely closed, if I don't rotate at all, then that would be 0 degrees. If I rotate so much that I rotate, all the way around and complete one full revolution, that would be 360 degrees. And there's a couple of sort of key places that we want to make a note of. For instance, we want to know what a 90-degree angle looks like, what a 180-degree angle looks like, and so forth. So we'll examine those in particular. An acute angle is an angle that measures between 0 and 90 degrees. So like I was saying before, a 0-degree angle would be like if you had this horizontal ray and then didn't rotate it at all. So it's almost like you don't even see the other ray. It's just right on top of it. That would be a 0-degree angle. And then a 90-degree angle would be if you rotated it so that you would make so that the two rays are what we call perpendicular. We talked about perpendicular lines earlier in the year, and basically it just means they intersect at 90 degrees. That's what a 90-degree angle looks like. We can notate this with a little square here to show that, hey, this is a right angle. And so if your angle measures in between 0 and 90, so like if it looks like this one up here that we already drew, that would be an example of what we call an acute angle. So that's what an acute angle would look like. Maybe I'll make this, can I make this smaller? No, that's all right, I'll just leave it like that for now. So that would be an acute angle. A right angle is one that measures 90 degrees. So that would be like this angle measure that I sketched out over here. Now, if you rotate more than 90 degrees, then you get what is called an obtuse angle. So an obtuse angle looks kind of like this, where you have your horizontal, and then you rotate more than 90 degrees. So let's say I'm like way over here, and the angle measure in question is this one right here. So notice this is a larger angle measure than 90 degrees. That would be an obtuse angle if it's in between 90 and 180. Now 180 would be half of a revolution. Remember I said if you revolve this all the way around to where that ray ends up back where it started, that would be 360 degrees. Half of that is 180 degrees. So what this is going to look like is, well, it's just going to look like a straight line here. Okay, so let me sketch that out real quick. So we just have basically a straight line where the vertex is just somewhere on that line. This would be an example of what we call a straight angle. So a straight angle measures 180 degrees, and then half of that would be 90 degrees is a right angle. So let's say like the vertex might be here. The vertex is here, the vertex is here. I didn't really include those points up there. But this is a straight angle, okay? It's half of a revolution. And so this angle right here would be, oh, that's a little big, would be 180 degrees, okay? Now, congruent angles are angles with the same measure. So if you have two angle measures, and if you have two angles, and they don't have to be in the same place, that's kind of a cool part of it. If you just have, let's see if I can draw this a little nicer. So let's say I have an angle that looks like this, and I've got another one. Well, I don't need to redraw it. I guess I could just copy. I've got some other angle measure that has the exact amount of revolution as we had in the first one. Then these are going to be called congruent angles. So last time we talked about what it meant to be congruent segments. Well, you can also have congruent angles. And with a congruent angle, the way that you're going to show that they're congruent are with these little curvatures, these little curves that we're showing where the angle is. And frequently you'll see that the number of markings on here will indicate what angle measures are congruent. So if you see like two little lines like here's an example down here where you see these two little lines. If you see the two lines here and two lines there, then that means that this angle is said to be congruent to this one, meaning they have the same angle measure. They don't have to be in the same spot. They just have to have the same angle measure. And so when they do, we call them congruent. Now an angle bisector is a ray that essentially cuts the angle in half. And so if, let's say you had like a 90-degree angle, so let me copy this one up here. I don't need all the rest of that stuff, but I can delete those in a minute. So let's say I have this 90-degree angle measure. An angle bisector would be one that cuts it in half. Let me use a different color here. So you would want like a 45-degree angle, right? So if I draw this precisely to where it's cutting this angle in half, where this angle is equal to this angle, that's what we call an angle bisector. So any problem that refers to an angle bisector is saying that you're going to cut this angle into two congruent angles. So like down here, well, we'll get to there. I don't want to get ahead of myself. So this is a pretty comprehensive list of the vocabulary we're going to use for today. There's a lot of other vocabulary that we'll get to next time, and we won't even really cover everything. I'm going to leave some of the terms for you to learn next year in geometry. But let's talk about a few more things here. For example, we can name angles a few different ways. Now, as I said before, we always measure angles in what we call degrees. Okay, and like I said, your revolution could be anywhere from 0 to all the way around to be 360. But the way we're going to name these angles, there's a couple ways you could do it. You can either name it by a number. So for instance, if this is the angle I'm trying to refer to, I could name it angle 3. Okay, see that little number there? Just indicating which angle we're talking about. So that's one way you could name the angle, and you use this little symbol here that looks like an angle, also kind of looks like an italicized L, and that just means angle. Okay, so angle 3, that's one way to name this. You could also name it by just stating the vertex. That's a pretty common way to do it. Now, if you have two angles that share the same vertex, that's not the best way to do it because It's not like if I go down here and I just say angle S, well, it's not really clear if I'm talking about this angle or this angle or this angle. So this is really only good notation if you've got like an angle kind of by itself, not connected to anything. It's not really the greatest way to name it, but it is valid if it's not unclear. So if you do have something like down here where you would not want to call this angle S, the way you would name it is by referring to the other points. So like if I want to talk about this angle up in here, you can kind of see what that would be called, would be RSP. So the key thing to do is to make sure that your vertex is the middle letter when you name it like that. So like if I wanted to name this using those three letters, I could call it VUT, or, you know, that's not really the only way you could do it. You could also call it TUV. Okay, either one of those is essentially the same. We're talking about the exact same angle. It doesn't really matter which one comes first. What does matter is that you put the vertex in the middle. So you could call this VUT or you could call it TUV. Either way is fine. And so let's see, to name angles, you can either name it by the number, like we did here, angle 3, or you can name it by the vertex point, like I did here, angle U, or you could name it based on the 3 points, just making sure that that vertex is in the middle. Now that brings us to our angle addition postulate, which is very similar to our segment addition postulate. Basically just saying that the measure of these angles, so like for instance the measure of this angle RSP plus the measure of the angle PST, if I add this angle right here to, well, let's try to get something, maybe not okay. So if I measure this angle right here, and let's say I get like 30 degrees, and let's say down here, let's say I don't know what it is, but we say it's 40, then if I want to know the overall angle here, the measure of RST, I could just add those together. So the way to write this, there's a special notation in geometry, is you put this little m in front of it, and what that means is the measure of angle RST. So the measure of the angle is what actually has that numerical value. When you say, oh, it's 45 degrees, what you're referring to is the measure of the angle. So the measure here of RSP plus the measure of PST would equal the angle, the measure of angle RST. Let's look at an example. Down here we've got what is known as a protractor. This is something that you may want to invest in for next year. It's very helpful to measure angles, and it's important that you know how to read it. So there's a couple of different ways we can identify these angles, and we will go back and classify them in a minute. But like let's say we wanted RQU. So that would be, let's see, RQU. RQU would be this one. Okay, so it doesn't really matter if you take the top numbers or the bottom ones as long as you're consistent. So, and then you just want to find the difference between the two angle measures where they're pointing to. So let's say we want to do the top. So RQU would equal, okay, so where is RQ? That's pointing at 180. 180 minus, over here looks like 55. Okay, so 180 minus 55 is, break out the old calculator here, don't want to make any mistakes, 125 degrees. Now, we could also calculate the measure of this angle if we looked at, instead of looking at this top number, we could also look at the bottom number and say, okay, well, this could also equal, let's go ahead and make a new little statement here. This could also equal, let's see, so RQU is this angle right here. So if we're looking at the two rays, we could say this equals 125 okay, minus 0. So the bottom number being 125, the bottom number over here is 0. So you could say 125 minus 0, and look, we get the same thing, which is 125 degrees. Oh, doesn't like that. There we go. Okay, so you can see that we can calculate it either way. So as long as you're consistent, it doesn't really matter if you're looking at the top number or the bottom number, but just make sure that you're looking at the same, like in other words, both numbers are the top number or both numbers are the bottom number. So let's find TQU here. Now, TQU is going to be, let me erase this other one. So we're not looking for that one anymore. Instead, we're looking for TQU, which is this angle right here. So we look to see where those two rays intersect the protractor. And so if I'm using the top number, I would say that this equals, let's see here, top number here would be 90. The top number over here is 55. So 90 minus 55 is equal to 35 degrees. Now, if I were looking at the bottom numbers, I would say 125 minus 90, which I get the same thing. I get that 35 degrees. So you can see it doesn't really matter if you do the tops or the bottoms. Just make sure that you're consistent, okay? For the next one, UQS. So UQS is this angle measure right here. Let's go ahead and erase this one. So now we're talking about this angle right here. So U is either at 55 degrees if you're looking at the top, or 125 if you're looking at the bottom. QS is pointing towards either 145 or 35, depending on the perspective here. So let's start with the tops. Okay, so the tops would be 145 minus 55. And that would be 90. Oh, look, we get a right angle there. Very nice. So we get 90 degrees. That does kind of look like a right angle. Yeah, these do look like they're perpendicular to each other. So that's nice that turned out that way. Now, if we looked at the bottom values, we would see that we've got, let's see, over here, you've got 125 minus 35, which is also 90. So you do not have to calculate this twice, by the way. I'm just really trying to showcase that it doesn't really matter if you use the tops or the bottoms. You're going to get the same answer either way. Just make sure you subtract the bigger number minus the smaller number. Okay, so if we want to classify these, and that's sort of the second part of this question, classify each angle, then we want to say, okay, well, 125 is bigger than 90 degrees, so that's an obtuse angle. 35 degrees is less than 90, so that would be an acute angle. 90 degrees is 90 degrees. That is what we call a right angle. Now let's get into some algebra. Let's take advantage of all the algebra we've learned so far and try to answer these questions down here. So it says, given that PQR is 102 degrees, so PQR would be, let's see, PQR is this big one. That's the 102. Write and solve an equation to find the measure of SQR, which is this angle right here, and PQS, which is this angle over here. So we're going to find like this one plus this one. Or not plus, but, well, yeah, I guess we are going to have to set that up as plus. So what we know is this angle, the measure of this angle plus the measure of this angle right here is equal to 102. So the setup here is we're going to say 9x plus, let's write an equation, 9x plus 11 plus 7x minus 5 equals 102. And what we're going to do here, the overall strategy is going to be to first solve for x, and then we'll plug in x here and here to find the two angle measures. So 9x plus 7x is 16x. 11 minus 3 is 6. And then that equals 102. We can then subtract 6 from either side, which leaves us with 16x equals 96. And then if we divide both sides by 16, we're left with x equals 6. So that's not, it doesn't really ask us for x, although we must solve for it so that we can answer these two questions. But there you go. So we've got x, and so now we're going to find the measure of angle SQR. Let's do that one first. So that would be, if I erase this real quick, SQR is this one right here. This one is labeled as 9x plus 11. And luckily we know what x is now. X is 6, so we could do 9 times 6 plus 11. And 9 times 6 plus 11, that's something you can just throw in the calculator, and we end up with 65 degrees. So we got SQR. Now we need to find the measure of PQS. So there's two ways we could do this. We could just plug in the x value we know. So just do like 7 times 6 minus 5. That might be the easiest way. Or, since you know the overall angle is 102, you could subtract this from 102. You could do it either way, but I'm going to do it the former way. So the measure of angle PQS is going to be equal to 7x minus 5. We've already established what x equals. 7 times 6 minus 5. And then if we plug all that into our calculator, we don't have to do the arithmetic in hand here. We get 37 degrees. So now we've solved for both the measure of SQR and PQS. We've got both of them. And we're going to use this technique where we first find for x, solve for x, and then plug that in both of these expressions on the next couple of problems as well. So let's look at number 3. So number 3, we've got a straight angle. Okay, so we need to know what straight angle means. If you don't recall, you can always scroll back up to where we defined everything. A straight angle is an angle that measures 180 degrees, and that's going to be sort of our key piece of information here. We're going to solve this similarly to how we solved the last one. So we're going to say that the sum of these two angle measures is 180. So when I say the sum of the two angle measures, I'm saying 10x minus 5 plus 4x plus 3 should be 180. If I combine my like terms, I get 14x minus 2 equals 180. Adding 2 to both sides gives me 14x equals 178. And then dividing both sides, oh wait, no it doesn't. I gotta add 2, not subtract 2. What am I doing here? That'd be 182. My bad, y'all. Then if I divide both sides by 14, I get x equals 13. And if you're not sure, like, don't be afraid to use a calculator here, y'all. I know you can't see my face at the moment, but I am using my calculator here. So just to kind of show you what I'm doing here, I'm saying 182 divided by 14. Don't think I'm like some whiz that can just come up with this super quickly. I am using a calculator over here, and I encourage you to do so as well. Okay, so we've got x, and now we can use x to find both the measure of KLN, which is this one, and NLM, which is this one. So what I'm going to do here, just to kind of save myself a little bit of typing, is copy my work from the previous problem and just change all the letters and numbers. It's just going to be a little easier for me to do that in Canton here. So KLN is 10x minus, whoa, what happened there? Okay, I'm not sure what happened there, but KLN is 10x minus 5, and NLM is 4x plus 3. We are going to plug in the value of x that we established earlier, which is 13. So we got 10 times 13 minus 5, and we got 4 times 13 plus 3. Both of these are expressions that we can evaluate in the calculator with relative ease here. So 10 times 13 minus 5 will be 125 degrees, and 4 times 13 plus 3 is going to be 55 degrees. So we worked both of these two problems basically the same way here. Okay, well, first we found x by using the given information to know what the sum of the two angle measures are. Like in this case they're 102, in this case they're 180. Just a little note here, you got to remember that a straight angle is measured at 180 degrees. Okay. The next problem is going to be set up similarly to these two, except they're giving us information that instead of it being a straight angle or giving us the actual value, they're saying that this EFG angle is a right angle. Okay, so if you don't recall, you could go back up here where we define a right angle as being a 90-degree angle. Okay, that's where your two rays intersect each other perpendicularly. So we know that EFG is a right angle, meaning that their sum is 90 degrees. Make a little note here. And so when I set up my initial equation, I'm going to say that x plus 1 plus 2x plus 2 equals 90. And then when I go to solve that, I combine my like terms and I get 3x plus 3 equals 90. I can subtract 3 from both sides to get 3x equals 87. And finally, divide both sides by 3 to get x equals 29. So that's my x. They don't actually ask for x, but I need it for these other two. And so let's see what they want first. The EFG. And do what I did on the last one, just kind of copy my work over here since it's going to be, should be basically the same setup. Might need to make a little bit more space here. Scoot this over a little bit. Scoot this over here. Is that going to give me enough space? Yeah, barely. Okay, that should work. Okay, so first we want EFG. So EFG is here. EFG. Oh, wait a minute. EFG, we know what EFG is. That was actually given as a right angle. EFG is a right angle, so we know it's 90 degrees. We don't have to work at all for this one. How great is that? I was not expecting that to happen, but there we go. We don't need the rest of this. It's going to let me move this box. Oh, there we go. Okay. I'm not crazy about how huge it is, but whatever. Okay, you guys get the idea. All right, well, that's great. That'll give me a lot more room to work this one out. I'm going to move this over so it's not so cluttered. Okay, so the next one is HFG. So that's right here. HFG would be x plus 1. We know what x is because we solved for it earlier. It was 29. So we get 29 plus 1, which is, that one you don't even need a calculator for here. Come on, y'all. That would be 30 degrees. Okay? So if this is 30 and this is 90, if they did ask for EFH, we could just find the difference between those two, which is 60. This would be 60 degrees. Okay, we've got one last problem here, and that's saying that VB is a ray that bisects AVC. So we might want to sketch this out. And before I do, let's make a little note here that, hey, there's something going on with this. Let's see if I can zoom in a little bit. This did not come out correct on just the way, when this printed. I'm not sure why this happened, but this should just look like an arrow right here. Okay, this notation should look like this. I don't know why it got split up like that, but for whatever reason it did. So I'm just going to go ahead and fix that. Let's zoom back out here. Okay, so this is a ray that bisects angle AVC, and AVC is 158. So let's sketch that out. So here's my horizontal piece, and then I've got, oh gosh, oops, sorry guys. All right, so there, and then let's see, 158, the supplement, wait, did we talk about that yet? No, that's next time. So if I do 180 minus 158, that gives me 22, so I want this at 22 degrees. Let's see if I can get that. Oh, that's going to be a big angle, big old obtuse angle there. Close. That's close enough. Okay, so this right here is 158. And this right here is the 158. And then it says we have a ray, and before we actually get to the ray, let's, you know what we need to do here is we need to make this a little clearer what's going on. We've got these arrows, and let's label this angle measure by plotting some points on it. So if this is AVC, I'm going to put A here, I'm going to put V here, and then C over here. And let's label it. A, V, C. Okay, so we've got this ray, VB. Okay, so let's draw a ray, which is going to bisect these. Okay, so I'm just going to kind of estimate where that goes. Somewhere right there. And so basically what I want to show here is that this angle measure, since it's a bisecting, oh, that's too thick. Let's make that, since this right here, I'm going to do it with 2 lines here, this angle measure is congruent to this angle. Okay, so these are congruent, and we know that because VB, which I haven't sketched out yet, I should probably label, here's V, but where's B? B could be somewhere like right there. So this VB is going to bisect this bigger angle, which means that it's going to basically split it in half. Okay, so if I want BVC, it's just going to be half of this overall angle. So the way I'm going to set that up is I'm going to say the measure of angle BVC, which is what it's asking us to find, is equal to half of that 158. Okay, and half of 158 is 79. So this will equal 79 degrees. Nope, didn't like that. There we, nope, wrong symbol. Okay, having trouble clicking on here. So there we go. All right, y'all. Well, that's about it for today. We've gone over several different vocabulary terms as they are related to angle measures. We've identified what an obtuse angle measure is, an acute angle, right angle. We talked about what congruent angles mean. We even talked about what a bisector does, which is to kind of cut it in half. Let's see, acute, obtuse, right. What am I missing? A straight angle, which is 180 degrees. And what we're going to talk about next time on our last lesson of the year is we'll just go through some more vocabulary and talk about the relationships between certain kinds of angles. Well, that's it for today. Hope you guys have a great day, and I'll see you guys next time.